Hi Muchler Science students. Today we are going to be working through a note-taking guide together to learn about the three different types of boundaries for plate tectonics: convergent, divergent, and transform. Now in this box on the left-hand side, box 1 is what we're going to call it, we're going to list the various types of crustal movements. And then in box 2, we are going to describe the type of movement that is occurring in each boundary and any major geological events that may take place there. So the first thing that we're going to do is we are going to list out the different crustal movements at a convergent boundary. And a convergent boundary is a special type of boundary because two different things can happen at a convergent boundary. So the first thing that we want to talk about is a continental plate running in to a continental plate. So right here I'm going to write continent to continent collision. Now, when a continent to a continent collision happens, that means two plates that have land masses above sea level are coming together and are colliding into one another. When they do that, a lot of times mountain ranges are formed because they are pushed together and then they crumble upward to create mountains. So I'm going to write over here under major geological event that mountain building happens here. Okay. The next type, I'm going to list actually two more types of collisions that happen at a convergent plate boundary, and that is going to be between an oceanic plate, a plate that lies beneath the ocean, and a continent plate. Those two come together, and then an ocean and ocean come together. So we have oceanic and a continent. And when an oceanic and a continent come together, we don't call it a collision, we call it a subduction. And I'll explain that word in a second. The second type, remember I said, was oceanic to oceanic. Two plates beneath the ocean surface coming together. And again, we also call that subduction. Now remember, you can pause the video at any time to write down these notes and then play it again to continue with them. But a subduction zone is different than a collision because one plate is actually going to go beneath another plate. It's always the oceanic plate, the one that is more dense and heavier, that goes beneath the continental plate. And that process of subduction actually creates very violent earthquakes. It can also create volcanoes. So when we're talking about geological events over here, I'm going to add volcanoes and earthquakes to our list. Now you'll notice I did a little color coding. I made this continent to continent collision purple and mountain building purple because those two kind of go together. And then these subduction movements, I made this like pink color, and I wrote volcanoes and earthquakes in that as well. So it's just a way to organize your notes. A lot of students like to use color to do that, and here's an example of how color can really help to compartmentalize our information. Now we do need to draw a picture of what this plate movement actually looks like. And so what I'm going to do, I'm going to draw two different pictures. I'm going to draw one in purple of that continent to continent collision. And basically what happens is you have two plates, and I'm just going to draw boxes for plates, even though we know that they are not square in shape. A continent to continent collision is where those two plates just come together, and they collide into one another, and they create those mountain ranges. In contrast, a subduction, like an oceanic to continent or an oceanic to oceanic subduction, it actually has one plate, and it's typically the continental plate that's going to stay on the surface, and then the oceanic plate, I'm drawing it, I'll move my hand so you can see it. They're still coming together, but one of the plates is going beneath the other plate. Again, the same movement towards one another, just one is subducting under the other. And I'm going to write a little O here so we know that that's oceanic and this is continental, or it's oceanic to oceanic. Whichever one is more dense is going to subduct. All right, the second type of plate boundary that we're going to talk about is a divergent plate boundary. And for the divergent plate boundary, just a couple things that we typically use these words interchangeably: divergent plate boundary and continental rift. And a mid-ocean ridge. This is important to note because divergent boundaries can happen on land or beneath the ocean surface. So if it's happening on land, it's creating a continental rift. Remember, this word continent means land. If it's happening beneath the ocean surface, it creates this mid-ocean ridge. Mid-ocean ridges are sometimes called underwater mountain ranges. But what happens at this divergent plate boundary, it's the opposite of a convergent plate boundary. Those plates, I'm going to draw my two plates here, are moving away from each other. Now, as those two plates move away from each other, magma bubbles up to the surface and creates new land. You typically find the newest, youngest Earth's surface at a divergent plate boundary where that magma has risen to the surface, newly hardened, and created brand new Earth. At these divergent plate boundaries, there's a lot of different things that could potentially happen there. So we're going to list out some of them. So we seafloor spreading. Okay, so the seafloor spreads apart. That magma bubbles up to the surface and creates new, young land, new, young Earth. Ocean basins are created. You can have faults that are created there. I'm going to continue my list over here. I write big. I'm going to draw a little arrow. You can also have mini volcanic eruptions. When that magma bursts up to the surface, it can create that small volcanic eruption. And finally, at a divergent boundary, you can also have earthquakes. Now, I want to go back to what I was saying just briefly about the age of the Earth. Like I said, the youngest Earth is found at these divergent boundaries where that new magma bubbles up to the surface and it creates new land. The oldest Earth's surface is typically found at these subduction zones when one plate is subducting under another one. So we can write a little note off to the side. I'm going to use a different color. I'm going to just write youngest here by divergent boundary, and I'm going to write oldest up here where it says subduction. Now, there is one more type of boundary that we do need to discuss today, and it is a transform boundary. And transform boundaries can happen at both continent plates and at oceanic plates. So I'm going to just move my paper up a little bit more. There we go. And I'm going to write that underneath here. It can happen at continental plates so we call it a continental transform boundary, or an oceanic transform boundary. Now, for those at the transform boundaries, these are different because they don't come together and they don't pull apart. They actually have a horizontal motion. They slide past each other in a horizontal way. So I'm going to write that word. I'm going to write the word horizontal. Just grabbing a different color pen here. It's a horizontal movement. And those plates move past each other. So one would move this way, the other one would move this way. They move horizontally past each other or slide past each other. Now, every now and again, they get stuck. And then when they get stuck, a lot of energy builds up. And then when they finally release, a very large earthquake is created. Transform boundaries are often referred to as fault lines, or they also have earthquakes. One of the main ones that we're aware of here in the United States is the San Andreas Fault that is found out in California. It's why California has so many earthquakes. It has this transform boundary in the state that creates frequent and sometimes large-scale earthquakes. So major geological events are fault lines and earthquakes. All right. Now that's the end of our notes for today. You can rewind it, pause it, and replay any part that you need to in order to gain a better understanding of this content.